Hello, this is Moles video number 7 and it's all about percentage yield. It's AQA GCSE Chemistry spec 4.3.3.1 and it's on chemistry only, so if you're doing combined science you shouldn't see this in the exams. Right, so yield is the amount that you make from something. There's two phrases that we need to know to be able to calculate percentage yield. There is what's called the expected or theoretical, or actually sometimes even calculated yield. And what these three identical terms mean is the amount that would be made if all of the reactants turn completely into products. So I'll give you an example to try and show what that means, because I think it's going to be easier than to see it with numbers. Mookie reacts 14 grams of lithium with excess oxygen. So from video 6, oxygen is the excess, lithium is the limiting reactant, and that's the one that limits and controls how much we can expect to make. What we're asking here is the expected amount of product. So we know we don't need to worry about the oxygen because it's in excess. It's all about how much lithium we've got. Now, to work out how much you would make of a product, if you haven't, please go back and watch video 5 to remember about not really sure. Not is the number of moles. So the first thing we do here is we have to take the mass and turn it into moles, because whenever we're dealing with working out how much of one chemical we get from another, we need to use the balanced equation and the number of moles. So this is a mass, so sample mass divided by molar mass, 14, the 7's from the periodic table. Mookie has got 2 moles of lithium. Step 2, it's always about the ratio. What's the ratio of lithium to lithium oxide? Well, from the equation, it's 4 to 2. I'm going to simplify that. 2 to 1. For every 2 lithium, you make 1 lithium oxide. Oh look, we have 2 moles of lithium, so therefore you would expect 1 mole of lithium oxide. Just to go over and reiterate it, you get the mass, turn it into number of moles, look at the ratio, 4 to 2, which is simplified 2 to 1. So you had 2 moles of lithium, you would be able to make 1 mole of lithium oxide, and then if they ask you to put that in grams, then you would look at the periodic table and it would be 2 times 7 plus 1 times 16, so it would be 30 grams of lithium oxide. So that would be what you would expect. That would be theory, this is the theory, or that would be what you've calculated. 3 phrases meaning the same thing. However, in reality, you will not get a 100% yield. Not every single one of the atoms that you start with will end up being part of the product. And there are 3 reasons for this that you need to know about. The first one, sometimes you can have a reversible reaction. So the lithium oxide splits apart and goes back into the lithium. You just don't get what you wanted. The next bit is a simple one. Some of the product is lost, and that happens when you transfer it. This one's probably easiest to think about if you ever cook something and you have some of the mixture for, say, cake stuck to the bowl. You don't get all of it into the oven. The last one probably doesn't happen when you think about cooking. In this case, some of the reactants, they don't react as you expected. Instead, they might do a side reaction. So this tends not to happen in the kitchen. You don't start off making a cake but discover that you've accidentally made a pizza along the side. But with chemicals, sometimes the atoms might react in curious ways and make a different compound involving lithium and oxygen that is not the one we wanted. All 3 of these reasons will mean that if Mookie was to try the reaction he did there, he probably wouldn't get 30 grams. And what this gives is the actual yield. So We put this all together, and the percentage yield is the actual amount of the product you get divided by that theoretical amount, and then you just multiply it by 100 to make it a percent. So let's say for a different one, I'm trying to give an easy sum here. Mookie was expecting to make 24 grams of sodium chloride. He only made 12 grams. Find his percentage yield. So the 12 is your actual mass, 24 is what he expected in this new question, times it by 100, and it turns out that he got an exactly 50% yield. Okay, hopefully all of that makes sense for you. Here is an exam type question. This is probably worth 5 or 6 marks in an exam. There will be a lot of work for this. What I'd like you to do, pause the video, have a shot on your own, and then compare with what I get. Okay, so Tyler reacts 6 grams of magnesium with excess oxygen. He gets 8 grams of magnesium oxide. What is the percentage yield? And you're given a balanced equation. Great, just double check 2 magnesiums, 2 magnesiums, 2 oxygens, 2 oxygens. It's definitely balanced. Okay, so what we're going to do, we're going to read through the question. Excess oxygen, so the magnesium is the limiting one, so that's the one that controls everything. 6 grams, this is the sample mass, so we're going to have to turn this into number of moles. So not really sure as how we're going to do it. Not the number of moles, well, it's a mass, so we do sample mass 6 divided by the mass of 1 mole. Remember to look that up in your periodic table. This would get you a mark for having done that correctly. 6 divided by 24. So Tyler starts off with 0.25 moles of magnesium. The ratio step, let's look up here. We're being asked about magnesium and turning it into magnesium oxide. So the ratio is 2 to 2. Oh, oi. So let's make that easier. It's 1 to 1. So he would expect 0.25 moles of magnesium oxide. To be able to work out the percentage yield, we need to turn this into the mass. So we're going to rearrange the equation here. The sample mass is the mass of 1 mole times by the number of moles. I'm going to look up in the periodic table. Magnesium is 24, oxygen is 16. So the mass of 1 mole of those would be 40. Tyler was expecting 0.25 moles, so what he would end up getting is 10 grams, and that is the expected yield. Right, there was another number given in the question, and that was 8 grams of magnesium oxide. This, if he's actually getting it, is the actual or the experimental amount. To get our to get our percentage yield, take the actual, so what he actually ended up with, we divide it by what he had hoped to get, and we times by 100, and for this one, oh look, I've done one that I can do quickly on video, it's an 80% yield. Quick note, if you do this and you get a greater than 100% yield, then you probably got these the wrong way round. But a note for yourself, if you have over 100% yield, you've gone wrong somewhere, and go back and check your working. Cheers all.